students clocked in signed CBD forms for the AUA conference and held in Nigeria. We are therefore encouraging everybody, whether you are a student, whether you are industry, we encourage you to come and improve yourself. Alcohol is established as a matter of fact. Renewal of licenses, not just by payment of your renewal fees, but by attendance at compulsory and certified CBD.
Hi, I'm Dominic Spillane, computer engineer, and today I'm going to talk about how to schedule a YouTube live stream for a Zoom performance in advance.
All around the world, from anywhere around the world, we're going to do that to encourage you to get our Nigerian architects, even the local Nigerian architects, not the ones that traveled out, but the local Nigerian architects to be at par with his contemporaries, with his contemporaries from other foreign lands. Thank you, and I wish you the best as you join us and enjoy Ladi Lewis' second time around. God bless you.
Well, that was introductory remarks by the National President, Association of Nigerian Chartered Architects, in the person of Architect Monore and Emmanuel Omasone. Thank you so much for introductory remark. So before we kick off, I would like to ask, is Architect Ladi Lewis ready? Okay. So before we kick off, let's just do some quick housekeeping here. First off, we kindly implore you all to ensure your mics are on mute when the webinar presentation is in progress, and only on mute when required to speak or to do so. Second of, there's a hand-raising icon by which you can signify or call our attention if there's need for a question or input you would like to make in the course of the webinar. 3, we are also live streaming simultaneously right now on YouTube channel. So just in case your internet connection with regards to Zoom is unstable, you can follow us on Anchor Architect on YouTube, on our YouTube channel, Anchor Architect. Emmanuel, please, could you just type that down in the chat box so that people can follow too on YouTube, Anchor Architect on YouTube. Then the last but not the least, there's a dedicated phone number which you can text questions to, just to ensure that you are part of what is going on. The number is, the dedicated number you can send your text message to, is 081-30-510-341. I take that again, 081-305-10341. So that's the dedicated number, phone number you could send a text message to in the course of the webinar during question and answer session of the webinar. So that's WhatsApp. Yes. WhatsApp. Please, WhatsApp, please. Just WhatsApp. WhatsApp. So now I'm going to introduce the speaker for today in the person of Architect Ladi Lewis. You're welcome, sir. You have the screen.
Thank you very much. I'm going to share my screen, and I'm going to do an update of what we went through the last time. I'll be quite fast with it so we can catch up on the chapters that we've gone through. So you'll bear with me as we go along and present this. Please note that we would make this presentation available to you. I hope you can see my screen. Yeah, please, as you can see my screen. So I'm going to run through the earlier parts that we did and then move on to the chapters. It's quite a extensive document. Let me explain that this is just preliminary, or let's say first stage working drawings. That's it. You might find it a bit detailed, but working drawings can be more detailed than this. So let me take you through it. We're looking at a document for developing a pattern and a system of building construction documentation. And this can be standard in offices. It contains a checklist style format. You can add to it as you go along. And, you know, a future move is that this document will have a preliminary stage for sketch design, a preliminary stage for detailed design, a preliminary stage for design drawings, and that you could actually have minimal input into it for those types of drawings. Now, let me just go to the summary of what this manual is going to contain at the end of the day. You can see that we've done the introduction, the types of drawings, the schematic drawings, design drawings, detailed drawings, working drawings. I'll briefly go through that. We've gone through this before, but I'll briefly go into that. Then, you know, the coordination, requirement for coordination. Then we take the meat of the drawings, the title block, the schedule of drawings, then the key drawings, site plans, floor plan, reflective ceiling plan, roof plan, sections, elevations, and interior elevations. Then we also want to go into BIM, building information model. What is it? Then evaluate BIM 3D to 7D. Then really the introduction to BIM itself, you know, and BIM computer modeling, BIM computer visualization, BIM external and internal collaboration, BIM construction coordination, BIM for calculation, BIM for sustainable design, there's BIM for parametric object technology, BIM for computer manufacturing, BIM for documentation. Then we'll go into a summary and our references. So it's going to be quite an extensive document. It's a working document. So I'll briefly just go through, we've gone through this in the last presentation, so I'll just briefly go through. Drawings can be classified in the design development stage into 3 categories. Some would say design and detailed design can be merged into one. Some split it because you could have some little variations. So you have your schematic design, which could also have a subset called concept design, where you don't really have a building, but you have abstract sketches of what you want to do. So even on that schematic design, you could have a subset of concept, and then you have the design drawings, where you have an idea of what you want to do. At that stage, you have overall dimensions, overall layout. You have those basic things, inputs in it, but you've not really started collaborating. So when you go to detailed design, you are collaborating with the other consultants, mechanical, electrical, you know, plumbing, AC. You're bringing them in and you're having a detailed design. By the time you're going to your when you are now looking at the real working drawings, as you say it is, you've brought in workshop drawings, you've brought in details of every part of the building, and you're on site, putting things together. And as you know, on site, you also will continue, updating your drawings as new things come up, as issues on the construction site are dealt with. until you get to the end and you also have an as-built drawing. I can tell you that there is hardly any project where drawings are not updated at the end of construction as-built drawings. Now, so you would have this presentation, as you have seen. I'm showing schematic drawings from bubble diagrams to, some perspectives and some color drawings. So you can call it as schematic drawings. Where design drawings, you can see that there's a bit of outline and detail in it, and the architect has already brought out, his proposal, which can, at this stage, even be sent as a drawing, be sent for planning approval, or at least assessment, for preliminary assessment. So you have that as a design drawing. You can get full client approval and say, look, at this stage, we're moving into the real details of putting other things. You have your structural members or concept of the structural components at this stage. Now, at this stage, if you decide to change your drawings, it means you are starting afresh all over again. So you need to be careful, because here, if you've gone through the proper process, you've actually done quite a lot of work. Now, when you get to detailed drawings, here you're already working with other consultants. A lot of drawings are coming in, some subcontractors like AC and acoustics will be sending you drawings and all that. So you probably also will be looking at, a lot of specifications that will be finalized. And by the time you go into your working drawings, you are ready to build. So there are a lot of details that were there. You'll be thinking of waterproofing details, you'll be thinking of finishing details, you'll be thinking of specialist works that will be coming into the project. These are the drawings you use to build. So, as you can see, working drawings is this set of working is a construction manual, and it's supposed to be accurate. You're going to use them for tendering, contract documents, base information for statutory approvals, developing a construction program, and developing as-built drawings, review, and feedback source for whatever you're doing. And it must be comprehensive, sufficiently detailed, and it needs to be technically sound. Now, one part of working drawings is coordination. You need to understand that you cannot have a set of working drawings without serious amount of coordination between what you started off in the schematic design, what you're putting together with planning requirements, physical planning requirements, what you're putting together with mechanical, electrical, plumbing, and all other aspects. You need to coordinate at all levels. You need to avoid discrepancies in what you will put on your notes or your title blocks. The coordination aspect is key. And one of the things we notice is that for coordination, you remember the days when you were drawing manually with tracing paper. You had to put the structural engineer's drawings on top of your architectural working drawings, and of course they must be on the same scale, so you could overlay the structural members with your architecture. You see that columns are in the right position, concrete shear walls are in the right position, and they don't obstruct the architectural design. This also occurs even in computer-aided design softwares. Like ArchiCAD has the trace tool that you can place one sheet on top of another and you can overlay it. Even if it's a 2D drawing, you can still overlay it. And Revit too has that capacity too as well. So what you notice is that coordination becomes a key thing. You need to have a checklist of whatever you're coordinating together in your working drawings. It's very, very important. Those mistakes cost a huge amount of money on sites, on construction sites. So we'll go to the first part, which I'm going to run through since we've been doing. That's your drawing title block. Please make sure that they are accurately laid out. Make sure that you check them. You should have the architect's name, address, and details. You know, details. You must have the client's name, you know, on the drawing. You should also have the project name and address. This should be part of the details in your presentation of the title block. It's key. It's a requirement for planning approval from the stage of your design drawings. You should have your drawing title. You know, we've had a series of drawings coming up in by candidates who or architects who have a project for a commercial building, and then you're seeing the title reading residential. So this needs to be carefully checked at all stages of your production of working drawings. Project number, you should have a project number so you can, you know, track your projects. The project status, is it a schematic drawing? Is it construction drawing? Is it as built? Is it a measured drawing? So you should know the status. Or is it for planning approval? You should know the status of those drawings. Then the project team details. Who designed it? Who checked it? And if you want, you might have a final reviewer. So you can track who did what. You have the scale of the drawing. It's important that you have a scale so that people can reference your drawing and relate to it. It's important, even though it's recommended that, you know, contractors don't measure, but at times you need to be able to understand how things fit on the drawing. You have a drawing date, very, very important. You should know where reviews were made, which drawing came before another. So you don't issue out an old drawing, and then there's a bit of a calamity on site, and you're discovering that, oh, a lot of work was done, but the wrong drawing was issued. Then the sheet size, so that when printing, those printing your drawings will be able to relate to it. Now the drawing number, what, you know, you can have, if you have 100 sheets, 200 sheets, and there was an error, somebody spilled them on the floor. How do I arrange them? Drawing numbers are quite important on the, you know, on each sheet, on each sheet, so you can put them back together. Then a revision bar. This will address the revisions that you've made, one after the other. Drawing notes, which you can, you know, update all the work you've done on the drawings. Here you can put quite a lot of details to address, you know, anything that you want the person going through your drawings to note. And then your key plan, not plan, and the legend. If you have a lot of details, the legend is the best way to, you know, note them down on your drawings. Now you have the schedule of drawings, which is basically a list of all your drawings. So you have your location and key drawings. The more detailed a drawing, a project becomes, the more drawings you might need to have on your schedule. And you can create subsets and subsets of these drawings as you go along. You have your layout drawings, which are, you know, we've gone through already. You know, your plans, elevations, and all those drawings come in. And then assembly drawings, details that will relate to different parts of the drawings that become the whole when you put your drawings together. So here you have some callouts and some blown up details. Then you have components, you know, the various components, door schedules, and things like that that you put together for your project. So let's go to the key drawings, the site plan. On your site plan, of course, you have your building, which is the majority of drawings on site plan. You have that. Then, but people forget the roads, the walkways on site. You have your north direction. This is going to repeat itself on every drawing. It should be shown. Then grid lines. This you put on your site plan. It will form a part of all your drawings. Probably only your schedules will not have grid lines. But we see these grid lines help you track your drawings, your, you know, elements of your drawings from one sheet to another. You continually see them on practically every drawing you're producing, and you should put them there. Then you have the dimensions. This is key. there is no use having a grid line without having dimensions. Then you have the boundary lengths, bearings, and annotations. Always remember to note that those are key things you should have in your drawings. Annotations help people identify elements in your design and know the difference between one object and another. And then you should have your bearings. You could even have them in degrees, and you will have them in, laid out to show what angle they are to other objects, or to angles to maybe your building or structures on site. Then you have graded and ungraded site levels. This is also key for you to note in your drawings. It's no use having a site plan and there are no levels, but that's one of the major things that you're going to put in place when constructing the building. What's the difference between the level of the road and the site? What determines that? It's your drawings. And when errors like this are made, you notice that you see some sites where there's a lot of flooding because levels were not transferred correctly. And if you have contours, you need to show what the existing contours are and where you have amended them. Then your site services and external works. If you have sewage treatment plants, you have subway septic tanks, manholes, they need to be indicated. Any external services, and this can be very, very detailed work, which will include the fence, it will include lighting, external lighting, it will include your cabs, it will include your paving, which areas are grassed, all external works. You're having electrical works coming in, anything you put on the ground, tanks, diesel tanks, numerous elements of external works to be on that sheet. And you would have all these sheets I'm indicating, even on, separated, so that your details show clearly. Then you have a landscape plan. This will be a set of drawings on its own. And depending on how detailed your landscaping is, you could have a planting layout showing the plants, trees, numbered, and the type with photographs showing how the plants actually look like, their height, and their radius. You can imagine you putting a tree that actually wouldn't fit into the area because its radius is about 6 meters when it's fully grown, and your building setback is just 3 meters. So that becomes important when doing a landscape plan. How are you going to drain the site? Do you have some irrigation lines? So when we say landscape plan, it can be as detailed as it's required for the project. Both soft and hardscape, you might have retaining walls. So each of these elements we're saying, we also have a series of subset of checklists. You could even have, drains, French drains. You could have waterproofing required in your landscape plan. You could have landscape furniture of all types, gazebos, terraces, that will be part of your landscape plans. Next will be your set out points, dimensions for your setting out plan. This you might need to do the triangulation of your building as it relates to your building perimeter. And these are always tied to your beacon numbers on site at the corners of your site. This is very, very important. And we've seen site plans that really don't have triangulated dimensions for setting out the building. Next is specifications and keynotes. Here you would list items that you would like to describe. There could be specifications for the kind of paving stones. Are you expecting heavy vehicles on site, so the paving stones are not going to be the normal? You could be doing specification notes for the kind of fence. Is it concrete? Is it block work? Is it brickwork? What's the finishing? So there could be specifications for your manholes. Are they concrete? Are they composites that are pre-made already, pre-manufactured? Do you have external taps that you want to specify? External electrical socket, weatherproof electrical sockets. So these specification notes would indicate those specific elements. Then you have callouts. Do you need to blow up something? Yes, you have some element in your landscape plan that you need to call out, and at the scale at which the site plan is, you need to expand on it. So that becomes necessary to show which areas you're calling out. And then you have a legend. You could have a series of items in your site plan that you really cannot describe in writing. So you have a legend to it, where you have a number indicating that, and you have a legend where you describe what those elements are. So your steps, external steps, you might want to describe them. You might want to describe the kind of actual grass you have there, so you can have a series of details in the legend as to what kind of grass, what kind of the trees could be numbered. Rather than you trying to write the full botanical name of the trees, you put that botanical name in your legend. Then you have the statutory development data. Of course, everybody seems to put that in because it's a requirement for planning approval, where you may having your square meter of the site, built up area, percentage of landscape area, volume of the building, building height, in some cases, lettable area. You have your number of parking. You could even do a calculation for parking ratio. So some complex buildings have a full page for this statutory development data, because you might have to do a lot of analysis. It might be a complex of buildings where you might probably want to have you might want to have a series of data relating to your building code analysis, the analysis of the building as per exits, as per fire, as per escape routes, muster points and things that are how you've calculated them and the area set out. So statutory development data could be quite intense on some types of projects. Then you now finally review all your checklist items. It's a good thing to have this as someone checked it and someone checked it again a second time. It might be laborious, but it helps before drawings go out and you get embarrassed by what you sent out with so many errors in it, which if you had been reviewed, you would have corrected. So we now go to key drawings, our floor plans. Now, first is, before you start going through those details of doing that, get your client's approval of your design drawings. It's important before you move those drawings into working drawing stage. So your north point will show up again on your plans. Your grid lines from your site plan, you transfer them back again to your floor plans. It's a good idea to have this so that this could also help you understand how your floor plans relate to your boundary lines and your setbacks. So and it helps coordinate work from the setting out plan to the floor plan when they all relate together. Then you have dimensions. Clear dimensions are required. There's a problem I see when people use BIM softwares with automatic dimensioning, and you start to see unrealistic dimensioning, numbers arriving at, instead of 3300, you have 33999. These numbers you need to avoid because they can't be measured on site. So it's a problem we notice when we were doing drawings manually. Of course, the limitations of dimensioning would actually force you to to be rigid about having them at precise numbers, rounded numbers. But unrounded numbers can be very confusing and can cause alignment errors in the building. You probably will not notice them visually, but when it comes to laying of tiles, they start becoming obvious. So work towards rounding your numbers, so that they are figures that can be set out on site easily. And center to center dimensions, I always tell people, are the principal things when dimensioning buildings. It's the easiest way for the contractor to set out your building accurately. And whatever you want to fix can be, dimension to those center lines. Then the room names and numbers. It makes sense to have them so people can identify one space from another. It also helps you who is designing to know what the space is being used for. and then you can number them. So you can have also a legend for them, and then you can relate to them. Then you have door tags. This will help you transfer this to your schedule. And when you're looking at the schedule, you can look at the door tags and easily identify the doors. In schedules, when you look at them, they can be very, very detailed as well. So as I've said, this is just like a preliminary checklist. Each of these items has subsets as you go along. Then you have your window or curtain wall tags. Just like you have your doors, you also have tags for your windows, and if you have curtain walls or anything like that, you can have tags to them. One thing I also will tell people is that if you have cladding too, you can have tags to those cladding on certain walls. If you have special finishes, you could also detail that too as well. So they show where they are on the floor plan. Then you have your fitted furniture tags and fixture tags. You should be able to identify, wardrobes, plumbing fittings, and things like that. So fixture tags are important. So one wardrobe dimension may be different from another, and then even the number of wardrobes in the building. You could have detailed fixture tags for even the kitchen cabinets. This is always left as an afterthought in design, and of course can also be cost-consumable issues when they are not thought through. Then floor levels, very, very, very important. They help save a lot of cost on site because the contractor can identify the differences in levels, and you don't just use a line across a threshold as the direction, but you have those levels, and you can relate them to your external spaces and from the internal space from one area to the other. And if you have a building on a site that is has levels, has differences in levels, it becomes more important. In split level designs, floor levels are the only way to identify the difference between one space and another on the floor plan. Then your dimensions. Dimensions are key, and they need to be tied to grid lines, the grid line dimensions. And you need to go through the drawing to see that every element that needs to be built is dimensioned accurately and can be picked. You should avoid forcing your contractor to try to scale your drawings. So you need to look at every element in your building and see that you've put appropriate dimensions, and those dimensions can be tied to your grid lines. If you have a curve, you need to indicate where the radius will be and how that radius will relate to that curve. How does a contractor find that radius on your floor plan on site? Then callouts. The scale of which your floor plans are done, it will be required that you blow up certain key areas and call them out, and then put them, to a scale that each of the elements within the building can be identified. Now, relevant services locations. You could have ducts, you could have rainwater pipes, you need to indicate those. You could have gas pipelines, where will they go through? You could run pipes for air conditioning, you should indicate where those would pass through your building. Then, of course, your section lines. As your section lines start off, they are going to be relating to every part of your key drawings. They should be the same from one drawing to the other in the same place, because your sections come to your floor plans. You could also relate to locations in even your elevations, so that your drawings could be related together. Then you finally review everything on your floor plans. It's good that you have someone who does the work and another person who reviews it to check that person's work. That way, errors are avoided. So the next is your reflected ceiling plan. It's not something that is commonly done when you see a lot of working drawings. A lot of people think it's just required for when you have suspended ceilings and all that, and you have for office buildings. But in this day and age where you would want your artisans to be accurate, especially those your subcontractors putting in plaster of Paris ceilings, gypsum ceilings, putting in spotlights, LED lights, a reflected ceiling plan would help, and it shouldn't be an afterthought on site. So you would start with the base plan that you prepared, and then with the same north direction. So orientation is in the same direction, and then you have your grid lines that you transfer from your floor plans down to the ceiling, reflected ceiling plan. Then you dimension those grid lines as well. Please check that those dimensions rhyme. Now here you might have some off dimensions, things that because of the ceiling plan. Try and round them up, they help on site, because a lot of times the contractors will approximate them. And it might leave some things in the wrong position at times. So put the grid line dimensions there. Then the room names, they are required. Even though it's a ceiling plan, you should know what is below that, what's going to be below that ceiling. It might help, whoever is laying out the ceiling to understand, oh, this was a bathroom, I don't need to do this there, or something else should be put there. There are some ceilings that work well for areas that are external, work well for areas that are internal, if you know the differences. Ceiling grids and the ceiling itself, what is the size of the ceiling panel, and how would you fit them, and would you be having different types of ceilings? So if you have grids, you might want to have a ceiling that does not have a grid at the perimeter of the wall. You could have bulkheads. So having those grids and looking at and placing them will be important. Sizing them, scaling them will be important. If you have wood paneling, you show it. If you have tongue and groove wood strips, you should show them and how they fit at corners. Next, ceiling fixtures. These are your lights. You have a ceiling fan. You have air conditioning outlets. You need to indicate where you want them fixed. This could also extend to quite a lot of other fixtures. Things like firefighting, your smoke detectors, your sprinkler systems.
Please, all these guys that are disturbing, you should mute themselves.
They fixed on each ceiling panel. In some cases we see where they are not indicated, and then the artisan simply fixes the workman fix the sprinkler bulb off the center of the ceiling panel, and it looks ugly. So you should be able to indicate where those things are in your drawings. Then you have your levels. The ceiling levels also matter. What comes at this level and what comes at the other level. And if you have suspended and ceilings that are changing levels from one area to the other, you need to indicate those levels. You could have an area, like a smaller space where you want the ceiling dropped so that it's not uncomfortable and doesn't look like a tunnel. If you don't put those levels there, they'll probably use the same level for the entire building. So that helps, and you don't have to physically, start to change those on site and at an additional cost to the client. Then you're setting out dimensions and tiling directions. You should be able to indicate which direction you want the layout to be and how you want it tiled, and you dimension, the spaces in between them. This helps, get a uniform layout. You can, when you do relating to how the ceilings are going to be fixed, notes relating to various items, minute items that you need to describe. So you might attach numbers to them and then you describe them. And you might describe the finishing, you might describe the color, you might describe the thickness, you might describe some characteristics, should be specifically fireproof, to what extent. As you know, ceilings they're called horizontal assemblies. So you might be specifying that you must have some rock wool above it. You might have some fire damping materials above it So all that you would put in your specification keynotes. Then your call out for your layout and assembly drawings. On the ceiling plan, you have your call outs for various rooms, like the bathrooms or toilets. You could have specific call outs for those spaces because you have some special type of ceiling work that is going to be done there and some fixtures. So you need to actually enlarge them and show what they are. Even around columns, it becomes a problem around circular columns. How do you want that detailed? Then your section lines, as you brought them up all the way from your floor plans, will show up on your reflected ceiling plans as well, and onto other drawings. And then you have a legend. This is key because you might have a lot of lights of different sizes, pendant lights, flush ceiling lights, spotlights of different types and sizes. So this legend would allow you to describe and show what one element is from the other without, crowding up your drawing with a lot of write-ups. And then you review again all checklist items. It's important that that review is done and is checked off. So we go to the key drawings, the roof plan. A lot of roof plans are done with just simply the outline. Yes, you start with that, but a lot of elements will need to go into it. Of course, again, the north direction. So we have an orientation for your drawing. Then your grid lines, again, you need to bring them up all the way from the ground floor plan to every other drawing up to the roof plan. This helps, the contractor understand how you place your roof on your building, and even you yourself who design it. You can see the offsets, you can see the soffits that you're going to need to provide. Then you have the grid line dimensions required as well, so we can understand the roof layout better. Then you have your rainwater pipes, roof gutters. If you have a gable roof or a lintel roof with roofing sheets. Even if you have a concrete roof, you should have spouts. You could have rainwater pipes. You could have scooper drains. Quite a lot of elements will be in your roof plan. You could have details of what kind of floor drains are required. Then you have the roof structure arrangement. In the normal roof carcass arrangement, you show your pour lines, a section where you can cut out to show your pour lines, your roof trusses, and show what direction, they are laid out. In a concrete roof, you probably show the layers of waterproofing, insulation, screed, final floor finish you're going to have on them. So these are indicators that will come on the roof plan, and you could specify what they are. In some cases, you could have a slight overlap of those items on your roof plan to show the structure. Then your levels, the roof levels. This with CAD now makes it very easy for you to identify the roof level, especially when levels are not equidistant, from one part of the building to the other. It will be nice for you to show those levels, and those levels will transfer to all the other drawings, and that can give you a lot of accuracy in your building, in your drawings, and in your building at the end of the day. Then your set out, you should be able to know how far from the grid line your overhang is, and that would help, the contractor understand, how to lay out your roof and how those elements affect even buildings that are adjacent to your structure. Then your specification keynotes. Here you will be describing various elements, and that you note them, and as you know, those specification keynotes you carry out, to your legend as well. Then you have your slope direction. You need to indicate that, so that there is no confusion as to what direction water is going to flow on your roof. Even in a concrete roof, you're going to have that done too as well, to lay out your roof finish into specific drains. And there are quite a lot of drain types for roofs. There's a chain link drain, there are scooper drains, there are overflow spouts, there are floor drains of different types. You know the brand name Fubora, but that's just a brand name, but it's also would be indicated, you know, in your roof plan. Then you have callouts. You need callouts from various areas, callouts on the plan, in the plan, callouts that you can, you know, take down to sections of what that detail really looks like on your roof plan. Then you have your section lines. This also will be on your roof plan. So as you see, you can relate sections to every part of your key drawings in plans. And then your legend. Everything that you've noted out from your specs, you take it to your specification. Right, once you've written your specifications, you put it in your legend. All the things you put in your keynotes, your special keynotes, you carry them over to your legend, and you have a legend table. So this legend table would make it easy to identify various elements in your roof plan. Then you review again, and all your checklist items that, you know, have been put in your drawings, you make sure that everything is accurate, and your text, even spelling is important. When we start seeing spelling errors, it looks funny on drawings. You know, it shows a little bit of carelessness on it. Then you go to the key drawings sections stage. Here you have the outline of your section. I also want to indicate that a lot of people believe that BIM softwares give you accurate sections, neat sections. No, you still have to edit them and detail them and look at the construction details in those sections. So when you have your outline, you need to look at it critically, look at the junctions, look at the connections, and make sure they're accurate. So you also transfer your grid lines to your sections. You put your floor datums, that means your floor levels. So like your floor levels on your floor plan, your roof, your ceiling plan, your roof plan can be transferred to your sections. So that will help you coordinate this. Then you have your ungraded site level. You know, here you've done your design, you've changed the levels, you've changed that. You should show in dashes where those ungraded site levels are. This also helps your measurement of quantities to know how much excavation you might require on your site. Your room names and numbers also from your floor plans will now show up on your sections too as well. Helps relating the various floor plans to the sections. Your door tags as well. So in your sections, we can identify doors from one area together. Doors in the toilet, doors in the bedrooms, doors in other spaces. Then we have your window and curtain wall tags as well. This also will show up in your sections. Then your floor height dimensions. This is key that, you know, that you have them. Floor levels will change. You could have, as we indicated before, you had your floor datums, but you could have various floor levels that change from one space to another. So you might want to indicate that, you know, if it's a simple building where you just have, you know, general datums like that, but in a complex building, you could have multiples of floor levels from one space to another. Then your dimensions. It's key to have dimensions in sections. So you can relate floor to ceiling heights, assumed floor to ceiling heights. You might need to dimension certain things, not based on the bare concrete floor, but on dimensions that will be placed after the finishing has been done. So that helps, you know, in dimensioning your sections appropriately to know where certain fixtures will be. Then you also have callouts that will go out to your assembly drawings. You might need to call out various parts of your sections to show details and to show particular elements that are critical to putting up the building. Then you review again and go through all your checklist items. It's important that you review and you review before you pass on drawings to contractors or to other consultants. Reviewing helps to, you know, avoid a lot of mistakes. So we go to the key drawing elevations. Of course, you start with the outline of the elevation, which is practically what we sometimes see in a lot of drawings. People just put the outline on elevation and leave it there. No. A good working drawing will have the grid lines show up on the elevations. We'll have the floor datums show up on the elevations. Then we'll have on the ungraded site level show up on the elevations as well. So you can see how that would affect your elevation and your facade. Then you also have the window wall tags. These two will appear on your elevation. So we can see how those windows fit in with your elevations. You also have, if you have curtain walling and door tags, this also can be put on your elevations as well. And specification notes. It's key because a lot of times things on elevations are just drawn and are not described. So here you have your specification keynotes showing those various elements. Handrails, what are they going to be made of? The glass, is it aluminum? Is it stainless steel? Is it plastic? Whatever it is it made of? Whatever it's made of. Then your cladding too. You will put specification notes to them and describe them from your facade. If you have different thicknesses of plaster finishes, it is key that those things be shown on your elevations and not left to the contractor to try and decode. Then you have callouts. Elevations also have callouts. You might want to show specific details at a larger scale, scaled up so that you can see them, clearly. And it's important that, that is done. So if you had your elevations at scale 1 to 100, you might bring them to a smaller scale of scale 1 is to 10, 1 is to 5, 1 is to 25 to show those elements. And you might need to, call them out so that you can specifically look at it in detail. A lot of things are hidden on the scale 1 to 100. And, whatever those larger scales on which you're doing your elevations. So call-outs help you to describe in precision what you put on your elevations. You also now put everything on your specification keynotes into a legend, describing those elements and describing what they're made of. You could have bricks, brick finishing. What size are the bricks? What is the dimension of the mortar joint between them? So it's not something you're going to come up at a later stage and it causes confusion on site. So finally, we'll review all checklist items again at the elevation stage. So we'd like to stop here. Okay, we have been asked to continue. So we're going to go into key drawings, interior elevations. And this is another part of the working drawings that it's not really looked at critically, but they are quite important. And you see these elements show up in buildings where you now see things fitted in some odd places. Wall elevations are important in any type of building because there are elements that are going to be fixed on walls. So you start with the outline of the elevation, then you go on to the grid lines. They are showing up again on your interior elevation. So we can identify where that wall is in the wall elevation, in the interior elevation, and how it relates to your section and how it relates to the interior of your floor plans. Then you have floor datums. You need to know the floor levels. You could have floor datums for your concrete floors. You could have floor levels for differences in levels from one place to the other. And you could, you could indicate all that will be indicated on your interior elevations from one place to the other. You have also room names and numbers, which will come out in your interior elevations. You have your window tags, door tags, curtain wall tags as they show up, if they show up in your interior elevations. As you know, these interior elevations we are taking from your callouts. So we'll move on to the set out drawings, dimensional dimensions for all fittings and fixtures. It's key so that this shows where your ceiling, like your ceiling, your suspended ceiling, how far below your concrete slab is it? Your tiling, from what point to what point will your tiling be made? So this will show dimensions for that. Also, things like toilets, road holders, hand dryers. You need to show dimensions as to what height. Even sockets and switches, in particular, you need to show what height and how you want what dimensions they are above the floor. So those fixtures will be dimensioned critically on your interior elevations. Then you also have your setup dimensions for finishes, especially when you have tiling patterns on walls. Here you dimension from what area to what area is this type of tile, and for that type of tile, and it allows you to see how your building will look like, on your drawings. Then you have your specification keynotes. They are very small elements like lighting fixtures, handles, handrails, handlebars that you put specification keynotes to, and would allow you to carry that to your legends. You also have callouts for those specific areas. For disability use, a lot of callouts are required to show specifically where those elements are. For special ceilings that you want to have some special patterns in, you need to call out that also from your interior elevations. Then the legend, which takes up what you've taken from your specification keynotes, and you put them in your legend to describe in detail what those things are. It makes the drawings quite neater and tidier. And then you review again all your checklist items. And it helps to identify errors and correct them. So this is where we stopped for today. We reviewed practically everything we did the last time, and also gone through the items that are new. As you can see, this is just, I would say, an elementary checklist. Very, very elementary. Each of the items we noted have thousands of subsets that could come out of it. I've seen a checklist manual that is close to about 600 to 1,000 pages of various checklists of items to review when doing working drawings. And depending on the kind of project you're working on, it could be as detailed as you can be. I've seen what do you call it, site plan drawings that had 30 sheets of details in them. And as you can see, it depends on the amount of detailed information you want to hand over to your contractor. The more information you put into your drawings, the more you save on errors. You save a lot of money on site. You save a lot of wastage. You are able to understand how you can get your building done on time because you've actually reviewed all those things. So I'd like to thank you for listening, and we'll be waiting for your questions, and we'll be ready to answer them. Thank you very much.
Thank you. Thank you, Architect Ladilius, our distinguished guest speaker.
Awesome.
Thank you for a wonderful job. Your questions can start rolling in now.
Thank you so much. Thank you so much, Architect Ladi Lewis. That was an amazing delivery of what construction drawing documentation, which is a manual that will guide our ability to deliver on what we have conceived as architects. on site. Well, that was a well-detailed presentation. So from where you are, please, let's put our hands together for Architect Lade Lewis. You can just show your reactions. That was a romance job. Thank you so much, sir. Thank you so much, sir.
A big thank you, sir.
Thank you.
Yeah, thank you so much, sir. That was a well-presented seminar. But just a quick question. Hello, can I go ahead, please?
Go ahead.
Go ahead.
Okay, yeah, just a quick question. Sorry, my name is Dr. Raji. So I would love to find out if such checklists is something that could be made available maybe to practicing architects, so we can as well have maybe a guideline. Let's say, for example, not a particular drawing, it could just be a space, let's say a 10 square meter or 20 square meter space that is well detailed with all these forms of checklists. And it comes as a template for different programs, for example, AutoCAD, ArchiCAD, and the rest, Revit. So for those whoever uses such softwares can have them as a template to, further improve on, and then we can have a standard to work with. I don't know how possible that can be.
Let me answer the question. Yeah, let me answer the question.
Yes, sir.
The manual will be made available to you, but let me clearly say that working drawings is something you need to produce yourself. You are given the idea. There is no standard drawing that is going to guide you through how you produce your working drawings, because each design differs from another. So you can have the checklist. We still have to do the grudge work of going through item by item and identifying those elements in your design and attending to it. There is really no magic bullet for working drawings. I've tried to search for things like that you're talking about, and I've not found any. In fact, what I discovered is that most big firms abroad have their own in-house manual, and they will never allow you to see it.
Okay.
In fact, if you're leaving the office, you can't live with one. You can't take it with you. So it's like company secrets, I will tell you. But there are general standards, and these are the things we're talking about. These standards are here. You can go through this checklist. We're going to put it online for people to be able to access it. And we're going to show, it's going to show you can turn it into a checklist in your office. But you also need to work with it. Build your own customized format for the kind of projects you do.
Okay.
Some projects might require more details, some projects might require less. So depending on the project you're working on. So, but you have a basic standard. There should be a basic industry standard at working drawings. And from that, you can get more detailed with it. So that's my own advice is take the template, use it, and as you work with it, make it more detailed and customize it to your office standards.
All right, sir. That would be
great.
Answer
the question?
Yes, sir. Very well, sir. So sorry, one more question, sir. How do you incorporate this working drawing standards with building code? How do you marry both together?
Okay. Now, basically, when you start a project, you need to do a building code review of your project. Is it an assembly building? Is it business? Is it institutional? Is it residential? So you will extract the code requirements for your project. Kindly note that the code requirements are going to affect your design first. It's going to affect your floor area. It's going to affect your floor to ceiling height, the volume of your building. It's going to affect the number of doors, the size of your doors, the number of staircases, kind of materials you use, the firewalls that you are required. It's going to affect the kind of doors, in terms of the finishing of the doors. It's going to affect the size of your staircases and the position your staircases will be. So that would affect you. So what you need to note is that when you've gotten those code requirements and then you've started designing, those things will now show up in your working drawings. So let me give you an example. You wanted to indicate emergency fire door.
Yes.
You require 3 for the assembly space you have. So when you put those 3 doors, you're going to indicate them in your working drawings. Show up on your floor plans, show up on your sections, show up on your elevations. You might even do a call out of them. So they might have panic bars to them, panic locks to them. And they should open in the direction of escape, as you know. So all that will show up in your working drawings. So your code, the building code would have determined that. Of course, you know, in the building code, when it comes to staircases, it says that you must have handrails. And the handrails have specific dimension into them as per how it extends beyond the last riser.
Yes.
Or the first riser, and the distance between the handlebar and the wall. So all that will show up in your working drawings. There are standards to those. Where at the end of this program, I'll also give you like a, an appendix of manuals that you could check up these things on. Things like the architectural graphic standards. Even your ARC data has quite a lot of working drawings standards in them, with tendencies that overlook them. So there are a lot of books, your building construction books have a lot of working drawing standards in them that you can bring into your working drawings. So any other questions?
Thank you very much, sir. No, that will be helpful.
Hold on. Thank you very much. So that we can have a coordinated session here, I'd like to before we continue with our Q&A session, I'm glad that we listened to a thought-provoking, very insightful and instructive session so far. But before we go on, I'd like to bring up the organization I consider as our sponsor for this event, and that's TY Workspace. They actually gave us their facility to transmit and broadcast this webinar today. So I'd like to bring on the CEO of TY Workspace in the person of Mrs. Toyin Arolo. Mrs. Toyin, you have the screen, please, for 10 minutes.
Thank you very much, sir. Good afternoon, everyone. It's my pleasure to be here. And it's our utmost pleasure to have such a prestigious association having their session with us. So this afternoon, I would just like to take 5 minutes and tell you what we do. TY Workspace is a luxury office suite. We have 2 locations, one in Yaba, and our second is in Onikon. And we provide office facilities to discerning businessmen and women and freelancers. As architects, I can imagine that you've gone out on a mission, had to meet up with a client somewhere, maybe far away from your office, or you actually work from home and you need somewhere comfortable, somewhere suitable to work with. So we are almost 4 years old. We will be 4 in June, and we started out with our Yaba location. We have private offices, so if you desire complete privacy and an office that suits your needs for you to be the only one in there, then we're able to accommodate you. We also have shared spaces. We have what we call hot desks at our Nikon location, which is for anybody who wants to pop in for a few minutes to walk out of a space that is cool, comfortable, 24/7 electricity, pretty fast internet, which is what we're using to host this afternoon. I would like that you would check us out on our website. We have all the information about our space on the website. One of the things we are also big about is arts. So our spaces are adorned with beautiful arts on the walls, which are also for sale. So please come in and do check us out. If you have any questions, I'll be happy to answer them. All our pricing is on the website. You can book make a booking directly from our website. So it's tyworkspace.com. Yeah, and that's it. I want to thank you, sirs, for this opportunity to feature us, and we're happy to have you here once again. Thank you very much.
Thank you so much, TY Workspace, for having us here live at your facility. We appreciate your kind business gesture to us. So to take the Q&A session, I'll hand over to Omonade Adeomi to read out the questions.
Okay, to those who send questions, I'm going to be reading your questions one by one. And this is the first question. Can record drawings, measure drawings, and as-built drawings be regarded as construction drawings, since they are prepared after the construction process, and knowing that the purpose of the main purpose of construction drawings is to provide a graphic representation of what is to be built? Is it to provide a technical and graphic representation of what is to be built? If not, what stage of drawing or documentation can they be ascribed to?
Well, it seems as if you're asking a very academic question, but let me explain this to you. Your construction drawings are meant for a project you are going to build. Now, you mentioned record drawings, as-built drawings, and measure drawings. They all mean different things slightly. As-built is done on a project that was under construction, changes were made. And as those changes were made, the building was put up, and then you do a drawing, a final drawing showing what was there before and what the changes, the differences. So you have the original drawings to start the construction, you have what was built. So you see the differences. When you put the two drawings together, you can see the differences. A measure drawing is a building that exists already, and you simply want to have measurements made of it. So it's not you're not going to be able to show the details in the sections, because I don't know how you're going to cut through the wall and put those details in. So you can see that a measure drawing is a physical measurement of a building. You may not be able to put as much of technical details in it, except you're able to open up walls. You probably may not be able to notice where columns are in the measure drawing, because they might be inside walls. So that's what you call a measure drawing. It's a visual measurement of a building. So your sections in a measure drawing might tend to be, visual in sense, because it's after. In a record drawing, this will relate to buildings like buildings for conservation. You want to keep a record of those of that building. So it's basically used for buildings that are very old buildings that you want to keep. You want to measure and you want to rebuild them. Some of these buildings are done in 3D models. So you now have point cloud software that can be used to take 3-dimensional measurements of these buildings. So if you could, I think buildings like, I think one was done on Buckingham Palace, where they wanted to do drawings of the building as it is today. So softwares were used to, try and get measurements of the building, and you can see that in some places might be as tall as 20 meters, 30 meters, 40 meters. It becomes difficult for you to actually measure them the manual way. So all these drawings cannot be said to be construction drawings, because they are not meant to be given to a contractor to build with. So your construction drawings are your proposal to get a building built. So they have a lot of details that you have to stand by. They have measurements, they have bills of quantities attached to them. So you can see the difference between a record building or an as-built, record drawing and an as-built drawing. So I hope I've explained that.
Next question. The term working drawings and construction drawings were used interchangeably. Is there any technical difference?
Well, there is none, actually. A lot of people use the word construction working drawings, because it's meant for construction. The term is interchangeable most of the time. So really, when you say working drawing is something that you're going to work with, you say construction, it's actually a job too as well. So I'm sure I don't think there's any difference between the two. And it's always better to say construction working drawings.
There's absolutely
Can
no
someone
difference.
create
They're just
an additional
interchangeable.
drawing type out of the general arrangement, set for clarity in case there is too much information on drawing plans? For instance, have a drawing called callout reference plan, just showing callouts.
Yes, you can make your drawings as detailed as you want them. And most architectural firms have their style of doing their working drawings. And you can make it as detailed as you want. There are offices that would have specific, even, would I say, nomenclature to their working drawings. If you have not worked with them, you'll find it difficult to understand their working drawings. They have their own internal checklist, they have their own specific ways of detailing things. So if you're going to work with them as a contractor, they would have to take you through their working drawings. You can't just pick it up and then understand what they put in it. It's like the way doctors write prescriptions and pharmacists write prescriptions. So you can develop your working drawings to as much detail. It can even be coded to your own interpretation. As far as when you're giving it to a contractor, you can explain to the contractor what you want built. In some cases, I have seen working drawings that have 2, 3, 4 sheets of abbreviations. That's what I'm talking about. That are specific to details in that drawing. So if you don't have those abbreviation sheets, you will be lost on those working drawings. So, but the essence of the construction working drawing is that when you give the entire package to a contractor and he studies it, he should be able to get that building built as accurate as it is on the drawing.
Someone says that his question is on the reflected ceiling plan, and he asked, when the reflected ceiling plan is done, and let's say the mechanical consultant specified where the cassette AC units will be in the ceiling and sent to you, can you indicate also on the reflected ceiling plan?
Yes, you are supposed to coordinate the work of your allied consultants. So that's why they send drawings to you. That's why the detailed drawing stage comes in. That's probably the difference between the design drawing and detailed drawing stage. Where those inputs come in, you overlay them on your drawing and you indicate how it affects your own ceiling plan. You are the architect showing the kind of ceilings you want. If he puts his cassette ceiling plan between 2 grids, you probably have to let him know that, look, this thing is landing between 2 grids. It might be a problem aesthetically, it might be a problem, even it might be between 2 rooms. So you need to coordinate that. And when you coordinate that, it's the job of the architect to coordinate all those items. So you don't have in a wash hand basin, the tap is not actually in the middle of the wash hand basin, it's on one side. You need to coordinate that it's exactly in the middle as it is in the plumbing drawings or mechanical drawings, it is in your architectural drawings. That's why coordination is key at every stage. You need to look at all those items. You would require a lot of time doing coordination. As I say, the working drawing stage is probably the most intense part of your work as an architect.
Someone is asking, is sewage drawings details done by an architect or a mechanical engineer?
Sewage drawings are done by a mechanical engineer, but you as the architect should know exactly how they affect your architectural design. You should know where they're going to place them and how it's going to affect your structure. I can give an example of where there was a tight site and we needed to put the sewage treatment plant. And what we did was to put it between our retaining wall on the site and the basement wall. But we as architects had to know where these things were. So you're going to coordinate all this work. you're going to have technical meetings with your consultant as you walk along. Let me give an example of a building that recently we were working on, and the columns were falling inside the parking space because it needed to support the staircase. And we had to have a whole meeting to resolve that. And what we decided to do was to have a shear wall to carry the staircase and knock out those columns. So coordination becomes a key part of what you're doing with every consultant that produces their specialist drawings.
Then someone asked if they could get the copy of the PowerPoint presentation.
Yes, you can. We would make that available to you.
That's all for now. Thank you.
Thank you so much, Omolani, for coordinating the question and answer. There's someone in the room here with the hands raised up, Architect Chibuzo Ohane J. Sorry, I'm not at your name. You could kindly unmute your mic and ask or make your input. Architect Chibuzo.
Hello, good afternoon, everyone. Please, my question has been answered. I sent it via WhatsApp, so it was raised. My question has been answered. Thank you very much.
Sorry, we can't hear you, please.
You said the questions has been answered.
I sent it via WhatsApp.
Oh, okay. Thank you. Thank you very much. Okay. All right. In the absence of, okay, there's another. Is that Emmanuel?
Larry Konya.
Okay, Architect Larry Konya. Raise your hand. Can you unmute your mic, please?
Thank you very much for calling me. I hope everybody can hear me. I also thank Architect Larry Lewis for such a brilliant presentation. My question goes directly to, at what point, how do you compare the generation of a legend and how you develop a complete specification data sheet? That's the first one. The second part is your specification data sheet on each item that you want included in the construction. Would that be a document that's created on a different set of sheets of paper, or would they be included as part of your working drawings? Thank you very much.
Now, let me explain that question. As you're walking along, you know, your drawings are going from one stage to that's how it helps. Let me use this format to explain this question. There is the CSI Master Format software that is used in the US for specification writing. It comes in 3 stages. A stage for schematic design, a stage for detailed design, and a stage for construction documentation. So what it means is that you are building your specifications from one level to the other. So as you design, you're building that specification list. When you build up that list, you have the legend. So as your drawings get more detailed, that list increases. That's how it works. So you're going to continue to work on your project until that list is fully populated. So as details coming from your, like let's take a typical example. You're doing a small living room, and you specified this type of floor tile, wall finish, ceiling. You've put those specifications there, and you've put a legend describing what it is. It was at your schematic or your design drawing stage. At your detailed drawing stage, certain inputs coming from your mechanical engineer, your electrical engineer, you're going to coordinate the two together. You're still going to populate that your legend sheet again, because he might have put some lights. You might say, no, we want LED lights. No, we want spotlights. I want accent lighting. Oh, I want wall lights here. We've looked at design. So at that stage of detailed design, you're specifications are going to increase and your legend sheet is going to be more populated. So as you move along, your client might now say, look, oh, we're going to have some speakers. We're going to have some surround systems. We're going to have some special type of control systems now, building management system. You're going to add that. The drawings for the building management systems come in. You add that to your drawings too as well. Your specification notes are there. Your legend also gets more populated. As you're working on the drawings, others, maybe specialist works coming. So it's an ongoing thing. And also you remember that even during construction, you are going to continue to do revisions. And that's why the revision cloud becomes important. With the revision cloud, you're going to have, date and time and who revised what. So that your legend sheet could also have, could also have a revision cloud around it where there's going to be an updated drawing. So you are living in a world of drawings, you are living in a world of revisions that you are constantly going to be working on until the building is completed. And even after it's completed, you still might need to do additional drawings to effect certain changes and to effect improvements. Something new could have come out that will improve your drawings. So if you're producing drawings for managing the facility, you might also update those drawings as well. Let's say as you're doing the building, you are now completed it, you want to round up your as-built drawings. All your client says, look, I have this special camera that is wireless. It's going to be placed at the entrance and it's internet ready. They place it there. You're going to have to show it on your drawings. So your specifications and your legend sheets will update it too as well. So in your revisions, you state it there that, oh, we've added this to it. So it's an ongoing process throughout the development of the building. So I hope I've answered the question, sir.
Thank you very much, Architect Ladi. You answered the question. You still did not answer.
I can hear you.
We can hear you.
Sorry, can you hear me? Yeah, the format for which the specifications data sheet is presented, would it be presented within the context of the working drawing or as a separate document?
You can present them as a separate document. In some cases, the specifications are very, very detailed. Let me make this clear that what you put in the drawing is just for the contractor to be able to build your structure and place them. The details to those specifications cannot be in your drawings. Let me give an example. The specification for floor tiling would include how it's going to be laid out, how it's going to be, first, how it's going to be stored on site. Yes. Is it going to be laid 3 stacks high, 6 stacks high? Beyond 6 stacks, they start to crack. That also will be in the specifications. In what kind of temperature, under what kind of lighting conditions will they be stored are there in the specifications? Whether they can be stored externally, will they be affected by rain, water, will also be in the specification. You can't put that in your drawings. So there is what I call specification documents and manuals. Now, if you use the CSI master format, just like you created your legend, they have specific numbers because that is product specific. So it's that number you would put on your drawings. When you click on that number, it will take you to the detailed specification sheets that will take you through all these things I've said about maybe the floor tile. What kind of adhesive are you going to use to lay the floor tile? After you've laid them, how long does it take for them to set before you can actually walk over them? What chemicals are you going to use to clean them? What kind of grouts are you going to use? All that goes into specifications documents. Those you can't put in your drawings. So it's just in your drawings, it's just a description of that item and where they are in your drawing. That's what you can put in your working drawings. You will now have that same, those linked to specifications documents as per that material. Let me put like a generator. You're simply going to put the location of the generator and where it is on your drawing, isn't it? But the specifications for a generator will involve you know, how you're going to service it. How many hours of servicing does it require? What kind of oil do you put inside it? How long will the battery stand still before you need to recharge it and put, you know, servicing? How long is number of hours of working hours before it requires servicing? If it requires monitoring, those will be your manual. So that will not appear in your drawings. So basically, your working drawings is to be able to, for you to locate various items and place them in your building. The more detailed specifications as per how those materials are used, even how they are removed, if there are errors in them, you know, how they are sorted, maybe like tiles where you sort them. You know, you see on the carton, sometimes you write it that you must open like 20 tiles, sort them out because there are slight variations in color, all that, what kind of blades you're going to use to cut them. All that are specification manuals that you can't put in your working drawings. No, nobody does that. So you need to be clear about specification manuals and working drawings. Working drawings basically is to tell you, you know, what you need to place those items in your building, where they are, where they should be. You know, of course, you'll be able to identify what color they are, you know, and what thickness. Those basic informations will be there. In BIM softwares that are linked to specifications manuals, when you click on it, the series of specification sheets details will come up in the attachments on maybe a dialog box. So you can attach those Word files or Excel sheets to a BIM software drawing. So there's a link to it. So, you know, if you're on the internet, even on a simple 2D software, if you're on the internet, you could have a link. You click that link, it takes you to maybe a Google file or a website with all those specifications in it. So you can have links even to your legend if you so require such information to appear on your working drawings. That's another way it's done. So your contractor can say, look, oh, I want the specification manual. I don't want to go and open a book. So he clicks on that link, it's on the internet. It takes him to those details.
Thank you very much, Architect Ladis Luis. I mean, we could just go on and on, but I think we'll just take a couple of more questions. There's a hand raised. Akinbajo Olamilekan. Akinbajo, you could go ahead and unmute your mic.
All right, thank you. Good afternoon, everyone. My name is Akinbajo Olamilekan Samuel. Yeah, my question goes back to how can you relate construction drawing and approval drawing? Because when you do a construction drawing and when you take it for approval and you've been told that you don't need more than this sheet, what is the relationship, or what can you do, or how can the body, the body can regulate this in order to curb all these, the notion of all these, you don't need more than 8-10 sheets. What are you doing? So I think that kind of thing is really affecting we, the architects, because there won't be difference between when you are being designed and where a draft plan being designed. You understand what I'm saying? So that's how can you relate? How can you? Okay, thank you.
Yeah, let me answer that question. If you remember when we were looking at the different types of drawings, we started with schematic drawings. We went on to say you move on to design drawings, then we move on to detailed drawings. What I can tell you critically is that in most places in the world, you actually start your planning process from your schematic drawings. You get planning information with that. So your schematic drawings will be just block outlines of your building. Yes, it might be difficult in Nigeria because the planning people may not understand what you are, the actual information they want to see. They are used to seeing working drawings. But at the same time, if you produce a good level format of design drawings, they are good enough to get approval. Now, you might wonder why we're saying this. It's better for you to get your approval drawings with your design drawings without too much details in them, because you will not have spent too much money up front and then you now have to make major changes. And as you know, the planning laws change from time to time, even without you knowing it. There are places where it was residential overnight, it's now commercial. Now you produced detailed working drawings, and you're now going to planning authority with 100 sheets, and they are telling you now it's commercial, and you're going back to your client and say, no. If it's commercial, then we need to change our design. So there has to be stage presentation of drawings, and this is what I would advise, as it is everywhere else in the world. So you get your planning approval based on your basic outline drawings, because what you're looking for is your setback, your density, your built-up area, your volume of your building, number of units, parking space. And because you're going to file your drawings and stamp them, you don't want too many sheets. I've had that where we sent in about 32 sheets for just a single story building, and they said, look, give us the basics. We don't need all these extra sheets of details. So we have to reduce it to 19. Now, we are going to do our detailed drawings. We are going to go beyond the 32. We're going to have about 100 sheets. So that's the one you present to the building control agency. And that's the way it is everywhere else in the world, that your construction drawings are going to be approved by a building control agency. That's where they look at your details, where your firewalls are, how many hours rating are your doors, how many hours rating are your firewalls around your staircases, what kind of doors did you put around your staircase, and what direction do they open, and where the panic hardware to it. The safety requirements in your building are going to be checked. So we need to have that two-stage presentation of our drawings. It will help us be more efficient, because you will not produce too much work up front that require major changes. Because you produce about 100 sheets and they tell you, we need so and so change. That change might affect those entire 100 sheets. And that means like starting all over again. So stage presentation of drawings is to our advantage. Just like, they are insisting. I know the reason they are insisting is basically because they don't want too many sheets that they don't need to get your drawing approved. So I think it's something that we need to put together as a body of architects. Also let the regulatory body be aware of this, so that when you produce your drawings and they see your approval drawings, they don't think those are the final set of drawings. It shouldn't be. Your final set of construction working drawings should be as detailed as much as possible. So I hope I've answered that question.
Yes, sir. Yes, sir. Thank you.
Very well.
We could go on and on because it's a compendium of unending knowledge with regards to construction drawing manual. Howbeit, we'll continue the series. We have to wrap up at a point. We'll continue the series. We'll let you know via various social media outlets the next webinar session that will come up. Before I do that, once again, sir, I want to thank you, Architect
APC
Lewis.
announcement on APC seminar. APC seminar, please.
Here. And I know this is just the tip of the ice. Is it icing, right? Icing on the cake. Icing. Because there's so much more. There's so much more. There's so much more. And you can trust that you can come to the Anchor channel to receive all the information that you need to become the architect you ought to be. And I'm going to sign off on this note. Omolade, you scripted something on Zaha Hadid, a quote on your Anchor students ecosystem. You could want to share it with us as we wrap up this session. Omolade, you have the mic.
Actor Guntoye, please. Don't forget, hello? Actor Guntoye. Are you hearing me? Hello? Oguntoye.
We can hear you.
Yeah, Actor Oguntoye, don't forget to make pronouncements on the forthcoming APC seminar, please, for candidates, prospective candidates.
Zaha Hadid made a quote and she said, "If you want an easy life, don't be an architect. The truth is, the field of architecture isn't easy, and it's not for everyone. We are the chosen ones, and we didn't come into this field to settle for less or fail. Yes, it's not easy, but we must go through the process and show the world the great architects that we are. Whatever project we are handling now that seems so difficult, remember this: the field of architecture is tough, but you are stronger. If you weren't as strong as you were, you wouldn't make it this far. Thank you.
Thank you so much. Well, now you have it, now you know it. I mean, based on our discourse, our conversation this afternoon, going into evening, there's so much work that it entails for you to be an architect. It's not just the appellation, and there's so much that goes to being an architect. You are actually a compendium of knowledge, a body of, you embody a specialized knowledge that can transform and can change the world as a whole. So it's our ability to apply ourselves to knowledge that makes us, that gives us that, that brings us to have a niche for ourselves as architects in practice. So at this point in time, I want to sign off. I want to thank Mr. Emmanuel Owo for co-hosting with us here. Omolade Adeomi, and delectable presenter, facilitator, one and only architect Ladi Lewis. Please put your hands together for him. Thank you so much, sir. Thank you so much, sir. So stay tuned to the Anchor channel. Stay tuned to the Anchor platform. We have so much more in stock for you. So at this point, I want to say thank you. Coming from the Anchor executive here, signing off, Architect Bodre Oguntoye, the Anchor National PRO. Thank you so much, and God bless you. See you soon.